today it's 1.7, modeling with equations. Just a couple of things to note right here. So you do your homework assignment, at the very bottom of the page, there's this submit assignment button. And I'm pretty sure if you've already submitted the exercises as you go along, and you got the green check marks, then that button's not going to do anything. The submit assignment button at the very bottom doesn't do anything. Okay. And so, you know, it might get kind of frustrated thinking your assignment's not submitted, but if you submit each problem individually, they're submitted. Okay. Also, for homework extensions, if you've got a homework if you had a homework set that you didn't quite finish and you want to go back and finish it, then when you go to your assignments page, there should be a past tab that you have to click. Okay, so past tab, you have to click that, and then that will allow you to go back and see your old assignments and go and review them and then request extensions if you need it. Okay, so let's go ahead and get into 1.7. So so this is just a bunch of different problems, and as we go along, I'll try to give you formulas and stuff that are going to be useful that come up that are quite common. Okay, so number one, it says express the given quantity in terms of the indicated variable, and then the quantity that they want you to express is the average of 4 quiz scores. And so average is equal to the sum divided by the total number that there are. So here it would be the sum of the 4 scores. Okay, so the average would be the sum of the 4 scores, so that would be quiz 1 plus quiz 2 plus quiz 3 plus quiz 4 divided by 4. Okay, now we know each of the first 3 scores is an 8, so that's 8 plus 8 plus 8. And we know that the 4th score is a Q. Oh, they're calling the 4th score Q. So 24 plus Q over 4. Okay, so that would be the answer for that one. Okay, number 2. The total rent paid for an apartment if the rent is $725 a month. N is the number of months. So the total rent is going to be 725 times n, times the number of months. So each month you pay 725. So if there's 2 months, then that's going to be 725 times 2. If it's 3 months, then it's just times 3. And then whatever n is what it is. So that one is just 725n in dollars. So number 2. Feel free to do the homework as you go along. That might help you to pay attention. And if there's any questions, just let me know at any time. So number 3, a cell phone company charges a monthly fee of $30 for the first 1,400 text messages and 10 cents for each additional text message. Miriam's bill in June was $35.30. How many text messages did she send that month? Okay, so there's the monthly fee of $30 for 1,400 messages, right? So her bill is 30 plus $5.30. That's what her bill was. So this $30 covered 1,400 messages, right? And at 10 cents, and then so she had 1,400 plus something, it looks like. And that looks like 53 messages. So 10 cents for each additional text message. So that's going to be 1,453. 1,453 text messages in the month. I don't know. Is that a lot of text messages, or is that like very little? Is that like normal for someone to send that many text messages? Okay, I won't worry about that. Okay, so Phyllis invested $9,500, a portion earning simple interest of 4.5% per year, and the rest a rate of 4% per year. After 1 year, the total interest earned on these investments was $422.50. How much money did she invest at each rate? Okay, so interest is going to be the rate. This is simple interest. So later on, we'll talk about compound interest, which is just a different, which is different. Simple interest is that you take the rate times the principal times the number of years. Maybe that's not a good way to write it. Maybe it's better if I write it as RNP. I don't know. Okay, so anyways, this is interest. This is the rate. This is the present value, or the amount invested. And N is the number of years. Okay, it's supposed to be present. Oh well. So N is the number of years. Okay, now she took this $9,500 and she split it up into two different funds. So let's look at each one. So she has one fund is 4.5% rate, and the other one is 4%. Okay. And then the amount in each one. So if we let this one be X, then this is going to be 9,500 minus X. So she put X amount, so that 9,500, if she put X in there, then the other account is going to have the remainder, which is 9,500 minus X. Okay, now the interest, in this case, because it's 1 year, that means that the N right here is 1. So it's just the PR. So that means that interest is principal times the rate. Okay. So this is the present value right here, and this is the rate right here. Okay, but you have to convert this to a decimal. So this is, the interest would be 0.045 times X. So this times this. This one is going to be 0.04 times 9,500 minus X. Okay, then we're going to look at the total. You could add those together, but that doesn't help. Adding those together gives you 0.045x plus, okay, then if you distribute that, 0.04 times 9,500 is 380. And then distributing here, you get minus 0.04x. Okay, so the total is 0.005x plus 280. But we also know that that is 422.50. So that's the key right there. We get this equation here. Subtract 380. We subtract 380 from both sides, and we have 42.50. And then we take this 42.50 and divide it by 0.005. So divide both sides by 0.005. And we get 8,500. Okay, so that means that Okay, so if you come back up here, what I did was I said let X be the amount invested at 4.5%. So that's 8,500. So 4.5% is going to be 8,500, and at 4%, that's going to be 1,000. Because both of those have to add up to 9,500, right? So if this is 8,500, then this has to be 1,000 in order to reach 9,500. Okay, great. Any questions on that? Okay, so that's covering simple interest, which is a problem that you might encounter. The next one is rectangular garden. So rectangles, the area of a rectangle is going to be the width times the length. Now, it's saying that the length is 7 feet more than the width, right? So the length is W plus 7. Okay, that's what this means right here. Its area is 294 square feet. The area is the width times the length. So the area is the width times the length. The length is W plus 7 now. And that's going to be 294. Okay, so that's W squared plus 7W on the left. And I'll go ahead and bring this 294 over to the other side. And if I factor, let me see, I think is it 14 and 21? Let me see. Yes. So that means either the width is 14 or the width is negative 21, but it can't be negative, so it's got to be 14. And the length is 21. So that's 7 more than the width. So the width is 14 and the length is 21. You could also just guess from here, you know, two numbers that one of them is 7 more than the other one, and their product is 294. You look for ways to factor 294. Because that's essentially what we did at this point. We were just guessing at factors of 294, right? Whereas right here, you could have just guessed factors of 294, but knowing that one of them is 7 more than the other. Okay, so anyways, let's go on to number 6. A bottle contains 800 milliliters of fruit punch with concentration of 50% pure fruit juice. Oh no, Jill. He drinks 100 milliliters of the punch and then refills the bottle with the equal amount of cheaper brand. What? Whoa, this is crazy. Okay. If the concentration of juice in the bottle is now reduced to 48%, was the concentration in the punch that Jill added? Whoa. This kind of reminds me, I saw on the TV yesterday someone drinking someone else's juice. Maybe that was Jill. Okay, so anyways, let's set this up. So we have the original. Now, the thing is, the problem here is that you can add amounts and subtract amounts, okay? Those add and subtract just fine, but concentrations don't add and subtract very, very nicely. Okay, so the original amount was 800 milliliters, right? And here we're gonna have the concentration, that's 50% pure fruit juice. Okay, and then so this is the amount of the whole of the fruit punch, right? And then over here you can have amount of juice or fruit juice. So this 800 punch contains 50% fruit juice. That's 400 milliliters of fruit juice. Okay, now Jill drinks. She drank 100 milliliters, and the concentration is assumed to be 50%. So she drank 50 milliliters of pure fruit juice. Okay, then she adds it back, right? Then Jill adds back. And she added back 100 milliliters, but we don't know what the concentration is, and we don't know, and then so we don't know how much fruit juice. And then in the end, in the final analysis, there's 800 still in the thing, because like 100 got taken out, but 100 got put back. The concentration is now 48%. Okay, so the concentration was 48%. And so that means if you take 800 times 0.48, let me do a different color here. So 800 times 0.48 is 384. Okay, so this one is 800 times 0.48. That's how I got that one. So 384. Okay, so now, so that means, so this, when the original was 400, but then 50 was taken out, so it was reduced to 350 amount of juice. And then in the end, we ended up with 384. So that means this has to be 34. Okay. So that has to be 34. Which means that the concentration, since this is 100, that means the concentration was 34%. Okay, you guys see the logic there? Let me try to quantify that. So if we let x equal the amount of fruit juice Jill added. Okay, she added 100 fruit punch, right? But part of that is juice, part of that is something else. Okay. So 400 minus 50 plus x, so that's taking out 50 and then adding the x back, then the end is going to be 384. And you solve that, and you get x is 34. Okay, and then 100 times this has to give you 34, so that's 0.34. So 34% is the final concentration. Okay, so 34% is the answer. Okay, any questions on that? Okay, so we'll go to the next exercise. Candy and Tim share a paper route. it takes Candy 95 minutes to deliver all the papers, and it takes Tim 55 minutes. How long does it take the two when they work together? Okay, so for this kind of a problem, the best way to go about it is to think about what they can do in 1 minute. Because you can't, so like you can't just say, oh, 95. I mean, you can, but then you realize quickly it doesn't make any sense if you say, it takes her 95 minutes and it takes him 55. So together, let's just add those together. That would be 150 minutes for working together. And so, you know, you might add those together and be like, oh, 150 minutes. But then you think, wait a minute, if they're working together, shouldn't it take less time? And so then you're like, well, we can't just add those. So what do you do? So, but what you can add is how much they can do in 1 minute. How much of the routes they do in 1 minute. So Candy can do 1/95th of the route in 1 minute. And Tim, he can do 1/55th of the route in 1 minute. And then together, they can do, that you could add those together, how much they do in 1 minute. This is what they do in 1 minute. Okay, and then, so therefore it's going to take them 1 over that to do it together. It's going to take them 1 over that, because then it's the same logic. If here it takes Candy 95 minutes, so 1 over 95 is what she does in 1 minute. But if you started with this, then you could say, if it takes 1 over 95, then you just take the reciprocal of that. It's going to take 95 minutes. Okay, so likewise together, this is what it takes. You just take the reciprocal of this, which is this, and that's what it's going to. That's what it's going to take. We're working together. Okay, so that's just the logic there. Okay, so now, let me see. I put this in the calculator. Let me see. I'll put this in the calculator now. So 1, and then I'm gonna. When you do it in the calculator, you want to put parentheses around here and here. So 1 divided by, and then in parentheses put 1 divided by 95 plus 1 divided by 55. And I get 34.833. So it looks like repeating 3s, right? Okay, so that's going to be 34. So I'm going to plus 0.8333. So this is going to be 34 minutes. But then the question is asking seconds. Whoa, seconds. So what you do is you take the 0.833 part. So subtract the 34 on your calculator and then multiply by 60. Because this is minutes. So 34 minutes and 60 seconds and 50 seconds. 34 minutes and 50 seconds. Okay, let's look at the next one. Okay, the next one is distance, rate, and time. So for this one, we know that distance equals rate times time. Okay, so a pilot flew a jet from city A to city B, a distance of 2,300 miles. On the return trip, the average speed was 20% faster than the outbound speed. The round trip took 3 hours and 20 minutes. What was the speed from city A to city B? So what we're going to do is we're going to let R equal the speed from city A to city B. Okay, so I'm going to make a chart here, and the first I'm going to put A to B, and then B to A. And I'm going to try to put everything here. So distance, rate, and time. Okay, so you know that the distance is equal to the rate times time. That's what we were trying to exploit here. So here, the distance is 2,300 miles. The rate, we don't know what that is, but I've let R be that rate, so I'm going to put that there. The time, we don't know what the time was, so leave that blank. Okay, so from B to A, we have 2,300 miles, right? And we know that the rate was, it's 20% faster, so that's 1.2 R. So 20% faster, 20% faster is the same as like 100% plus 20%, so that would be 1.2 R. 20% times the rate from A to B. Okay, so the round trip took 3 hours and 20 minutes. So that's the total. So the total is 4,600 miles. And the time it took was 3 hours and 20 minutes. So that's 3 1/3 hours or 10/3 hours. Okay. So 20 minutes is 1/3 of an hour. So that's 3 1/3 hours, but 3 hours is 9/3. That's 9 plus 1, that's 10/3. Okay. And you can't add the rates. You can add the distances and you can add the times, but you can't add the rates. Okay, you can't add those. Okay, so, but what can we do? Well, what you want to do is exploit this right here. So I'm going to come over here and exploit this. These times right here, times can add together. So time is equal to distance divided by rate. So this one would be 2,300 over R, and this one would be 2,300 over 1.2 R. And then these can add together. Okay, so those add together. So that gives you 2,300 over R plus 2,300 over 1.2 R equals 10 over 3. Okay, so we have an equation here, and what you want to do is get the common denominator, because it's all fractions, and fractions are no fun. So the common denominator would be 1.2r times 3. So we're going to take each piece and multiply by that, 1.2r times 3. And here, 1.2r times 3. And then here, 1.2r times 3. Okay, and then a lot of things are going to cancel. So these r's are going to cancel here, for example. The 1.2r cancels with this 1.2r. And here the 3's cancel. Okay, and then so then what you have is 1.2 times 3 times 2300. I'm going to use my calculator to figure that out. 1.2 times 3 times 2300. That's 8280. This is 2300 times 3. That's 6900. And then over here is 12r. Okay, so 12r is, let's see, adding those together. $151.80. Okay, dividing that by 12. Divide both sides by 12, and you have 1265. Whoa. Whoa. That's pretty fast.